Hello, this is Ed Close again. I'm back welcoming you to Science and Spirituality TV. In this video, we'll review true units that we talked about in the last video and see how they explain things that are inexplicable in the current scientific paradigm. In the little circle on the left, you'll see a depiction of the hydrogen atom, the most common element in the universe, consisting of two up quarks, a down quark, and an electron. Modern science and technology depends upon our understanding of this little bit of nearly nothing, and yet the current scientific paradigm can't even explain why it exists. The close-snappy theory of everything does explain why it exists, but it involves some new ideas, and new science can be hard to understand because a real paradigm shift is inexplicable in the old paradigm. In this video, we'll see that the abundance of hydrogen and other things that are inexplicable in the current scientific paradigm become fully understandable in the new paradigm, the close-snappy theory of everything. This slide emphasizes how important language is, and mathematics is the language of science. When new science is discovered, the existing mathematical language must be adapted, expanded, or improved to express the new concepts. So to fully understand a new paradigm, one must learn the new language. The new language for the close-snappy theory of everything is called the calculus of distinctions. In the new language of the calculus of distinctions, with atoms described as combinations of elementary distinctions, quantum physics is simplified in many ways. Behold the dynamic electron, the mighty mouse of the particle world. The first step in the calculus of distinctions is identifying the smallest possible quantized distinction for use as the standard of measurement. The free electron is used to define this basic unit of the calculus of distinctions because it has the smallest mass of the three elementary particles, electrons, up quarks, and down quarks. Since the free electron, a symmetrically spinning object, defines the unitary distinction, we call the basic unit of measurement of the calculus of distinctions the triadic rotational unit of equivalence, or the acronym for short, we call it the true unit. You may remember this slide from the previous video. It is repeated here because of the importance of the true unit in the calculus and in the close-snappy theory of everything. When an electron is stripped from an atom, the volume it occupies shrinks. This is similar to what happens when a spinning skater pulls his arms in, and the spin velocity increases tremendously. Calculations show that the spin velocity of the electron reaches light speed before the volume shrinks to zero, and because no measurable velocity can exceed the relativistic speed limit, the free electron can only shrink to a minimum non-zero size. By setting both the minimum volume and mass of the electron equal to 1, we define the true unit, a truly basic standard of measurement. The basic principle of quantum physics, that is, the fact that energy and mass are quantized, means that the up quarks and the down quarks are composed of whole multiples of true units. In the previous video, we learned that based on particle collider data, they are composed of 4 and 9 true units respectively. We'll discuss this more in more detail in videos to come. Like the way the grammar of language reflects the logical structure of thought, The logic of the calculus of distinctions reflects the mathematical structures of numbers, which in turn reflect the structure of the universe. Knowing that electrons, quarks, protons, and neutrons are all multiples of a basic unit simplifies things considerably. The words, or distinctions, of our language, the calculus of distinctions, describing the physical universe, are multiples of integers, the numbers in the innermost circle in the diagram on the lower left. The other numbers, fractions, rational, irrational, etc., are intermediate products of calculus operations, and the so-called imaginary numbers, which you'll see in the little square and white circle to the right, exist in a dimension perpendicular to the dimensions of space and represent the fourth dimension of reality, and that is the first dimension of time. In 1637, Pierre de Fermat, a French barrister, an outstanding mathematician in his spare time, stated what became known as Fermat's last theorem. The sum of two squares can equal a square, but the sum of two cubes, or any power greater than 2, cannot equal a cube or higher power. Fermat claimed to have proved this, but his proof was never found, and Fermat's last theorem became famous because, try as they might, no mathematician was able to find a general proof for more than 300 years. It is, however, easily proved for 3 through 9 dimensions. Since all elementary particles are perceived as three-dimensional whole number multiples of true units, Fermat's last theorem says there are no whole number solutions to the equation representing the combination of two quarks. So that is, no symmetrical spinning particles comprised of true units can combine to form a third symmetrical particle. This means that two elementary particles stuck together will be asymmetric and therefore unstable as spinning objects. Because of their combined angular momentum, they will quickly fly apart. However, Fermat's last theorem applies to the combining of two spinning particles, but not 3. There are whole number solutions to the true unit equation representing the combination of 3 quarks. This is why protons and neutrons are composed of 3 quarks, and this is why they are symmetric and stable, and why there is something rather than nothing. We're all familiar with drawings depicting atomic and subatomic particles like those on this slide. Why are they wrong? They show that what we find by blasting an atom apart, not what it is like before as a stable entity. These oversimplified pictures reflect the reductionistic approach of particle physics, based on the unwarranted assumption that when a particle like a neutron is blown apart in a particle collider, the original neutron was simply all those pieces stuck together. The calculus of distinctions reveals an altogether different picture. By applying the basic principles of relativity and quantum mechanics and using true units to describe atomic and subatomic particles, the Close-Nippy theory of everything reveals something very simple, yet far-reaching in its implications. The elementary particles, the electrons and the quarks that make up protons and neutrons, merge when forming atoms. They do not remain separate as depicted in the Tinker Toy models we find in current physics and chemistry textbooks. We will see later in another video that this explains much of the so-called quantum weirdness. Assuming that everything is made of particles leads to the idea that there must be particles called gluons. These are the little wavy lines in this slide in between the red, blue, and green circles with U's and D's in them. So these little wavy lines called gluons are supposed to hold the quarks together, the quarks of the neutron and the proton. I call this the if all you've got is a hammer, everything's a nail syndrome, because everything is explained in terms of particles. But incidentally, the particle physicists say that the gluon particles have no mass or energy. Now this prompts the curious person to ask, if they are neither matter nor energy, what are they? Application of the calculus of distinctions, quantum and relativistic principles, and the famous mathematical statement known as Fermat's last theorem reveals that the strong force explained here as gluon particles is the result of the symmetry and intense energy of the spinning particles. In the neutron and the proton, the quarks merge into a single symmetric object. They're not just stuck together. The mathematical proof of this will be discussed in more detail in a future video. The three-dimensional physical universe of whole number valued distinctions of extent and content that we know as the physical universe is contained within a domain of even greater extent composed of 4 dimensions, 3 of space and 1 of time. By a process of rotation and projection called dimensional extrapolation, we find that the 4-dimensional domain is embedded in a yet larger 5-dimensional domain. With repeated applications of dimensional extrapolation, we find that 9 dimensions are sufficient to describe the geometry and dynamics of elementary particles. Applying the logic of the calculus of distinctions to this 9-dimensional reality, we find that mass is a manifestation of energy, and as Max Planck said, there is no matter as such. Elementary particles are multidimensional spinning vortices of energy arising from the interaction of the 9 nested spinning domains of space, time, and consciousness. The interpretation of the calculus of distinctions for application as symbolic logic reveals the fact that the solution of any math or logic problem that can be solved is always contained within the statement of the problem. And the more basic the language used in the statement of the problem, the easier to obtain and clearer the solution will be. Application of the calculus of distinctions renders many complex logic problems amazingly easy to solve. This makes it ideal for testing mathematical and scientific hypotheses. Applying the calculus of distinctions to long-standing cosmological puzzles yields some somewhat startling conclusions. For example, one is the universe is comprised of a 9-dimensional transfinite domain embedded in an infinite substrate. 2, time, like space, is 3-dimensional. Now, make a note here that past, present, and future are not the separate dimensions of time. Past, present, and future together defines 1 dimension of time. And 3, there are no absolute beginnings or endings, and thus no Big Bang, only change. The striking elegance of the mathematics proving these statements is detailed elsewhere in technical papers. There was no Big Bang. Perhaps the biggest science myth ever is exploded. Stay tuned to Science and Spirituality TV to explore the implications of three-dimensional time and learn why the universe appears to be expanding and the significance of so-called dark matter and dark energy, and much more. See you next time on Science and Spirituality TV.